You can start now.
Okay, so let's continue from where we stopped. We stopped at evolutionary arrangement or advancement among living things. So I was trying to explain using the vertebrates as an example. So among the vertebrates, that's animals that possess backbone, you start with the fishes, otherwise known as Pisces. So if you have options in your exam and a Pisces or a fish is in the option and they are asking you which one is the lowest in the evolutionary trend, you know that you have to choose the fish. Then after the fish, you go to the amphibians. Amphibians are the next in the rank. So the amphibians, we have example like the toad, like the frog, the salamander, the newt. So any of them, even tadpole belongs to that group. So any of them is the next rank after the fish. Then the next is reptiles. So the reptiles are crawlers. Okay, the crawling animals like snake, lizards, alligator, and so on. So that's the next rank. After that, you move to the birds. So the birds, also known as aves. Okay, you know examples of birds such as vulture, pigeon. Please, bat is not a bird. Remember that. Then you now talk of mammals. For the mammals, these are the animals that have hair all over their body and then an external ear known as pinna. You know, those are the mammals. And then they have a mammary gland. You know, so that's the movement. So I remember it with the code PARAM, P-A-R-A-M, P for Pisces, A for amphibians, R for reptiles, A for aves, and M for mammals. Okay, so that's exactly how it is. Now note that evolution does not mean that every organism must eventually become a human being. No, that's not what it means. Evolution simply means gradual change within a species that leads to new species of that same kind of species. That's what evolution means. Okay, so I hope we are good with biology now. So let's move to chemistry. Okay, we are moving to chemistry. So for chemistry, we are going to be looking at separation techniques, you know, and pure and impure substances. That's what we are going to be looking at in chemistry. So first of all, let's look at the concept of purity. So purity measures the degree to which a particular substance is contaminated. So if the substance is contaminated, we simply say it is impure. If the substance is not contaminated, we simply say it's what? It's pure. So a pure substance contains only one kind of chemical substance or only one kind of particle and has a definite composition. A pure substance generally has a sharp or constant boiling or melting point and then shows only one spot on the chromatographic paper. So these things I said now are the criteria for purity. 1, the melting point is going to be sharp or definite. But if it were impure, it will melt over a range of melting points. And the presence of impurity lowers the melting point or the freezing point of a solid. Then coming to boiling point, a pure liquid, because we use melting point for solid. So a pure liquid will boil at a sharp or definite boiling point. But if it contains impure substances or impurities, then it will boil at a higher temperature, and even it's not going to boil at a single temperature. It's going to be a range of temperature to represent the boiling point of each of those impurities. Okay. Then we have chromatography. The number of spots in the chromatographic paper indicates purity. So if we have only one spot on the chromatographic paper, then the substance is pure. But if you have more than one spot, then the substance is not pure. because each spot indicates a kind of particle inside the substance. Okay, so let's go down to the next slide. That's slide 22. Pure and impure substances. A pure substance, like we have said, contains only one kind of particle. So examples, we have distilled water, we have sodium chloride, we have oxygen. These are pure. Then impure substance example, we have seawater. In the sea, you have a mixture of different things. Then we have dirty water. Then we have crude oil. Okay. Then let's move to physical and chemical change. Physical change is a type of transformation that results in no new substance. So a new substance is not formed in a physical change, and it can be reversed. So example is melting of ice, boiling of water, dissolving salt in water, because you can recover these things back. So it is physical change. Then on the other hand, chemical change is a transformation that produces one or more new substances, and it cannot be reversed. So example is rusting. Rusting of iron is a chemical reaction. Burning of paper is a chemical reaction because you can't get that paper again. Then reaction between acid and base is a chemical reaction. The melting of candle wax, don't forget, once they say melting of candle wax, the fact that melting is there, we know that melting is physical change, but now they have said melting of, they mention something. Candle, when you light it, it will be melting. Why is it melting? Because it's burning. So any process that involves reaction, chemical reaction, is a chemical change. That's the difference between drying and dehydration. Drying is a physical change. Dehydration is a chemical change. So physical change, usually reversible, no new substance is formed, and small change in energy involved. Then chemical change, new substance formed, irreversible, and then large change in heat energy. So we are good with that. Now let's move to elements, compounds, and mixtures. Now what's an element? An element is a pure substance that contains only one type of atom. It is a substance that is made up of atoms that all contain the same number of protons and cannot be split into anything smaller by ordinary process. So we have about 118 known elements at the moment in the periodic table. So examples of these elements are hydrogen, oxygen, fluorine, neon, iron, copper, gold. Now a compound. A compound is a pure substance formed when two or more elements chemically combine by means of a bond in a fixed ratio. There is an unlimited number of compounds. Yes, they cannot be separated into their constituent elements by physical means. For example, sodium chloride is made up of sodium and chlorine. I can't separate sodium from chlorine by doing filtration or precipitation or sublimation. No, you can't do that. That's a physical process. If you want to separate them, you have to use chemical process. Reactions has to happen, okay? So that is for compound. Now, examples of compounds are water, carbon dioxide, sodium chloride, copper 2 sulfate, calcium trisulcarbonate 4. Now, notice something. All these examples I called now, they have a chemical formula. That's the way you know a compound. They have a formula that you can write with symbol. But mixtures don't have chemical formula. They can have formulation, like mix this, mix 2 cm cube of this with 5 cm cube of this with 10 cm cube of this. That's formulation. That's not a formula. Okay? So now a mixture is an impure substance which combines two or more elements or compounds physically without bonding, and there is no fixed ratio. So mixtures can be separated by physical methods such as filtration. Examples of mixtures are air, sand and salt, crude oil, oil and water, sulfur powder and iron filings, rice and beans. That is a mixture. So I hope we are following. Okay. Now, what are the methods we use in separating mixtures? Because we have already said that we cannot separate compounds. So how do we separate mixtures? So we have different methods. So we try to categorize them. So the first category, category A, is separation technique for separating a solid from other solids. We have three in that category. What are they? We have sieving. You sieve because the particles have different sizes. So sand is separated from gravel by sieving. Sublimation. You use sublimation when you have a volatile solid, a solid that can easily melt, and a non-volatile solid. Like ammonium compounds are volatile, iodine, volatile, camphor, volatile. So if I have a mixture of camphor and sand, or iodine and sand, or ammonium compound and any other compound, I can use sublimation. Okay? Then magnetic separation is used to separate a magnetizable solid from a non-magnetizable solid. So iron filings can be separated from sulfur by bringing a magnet close. Okay? So that's it. Now, category B, separating solid from liquid. You have, this is slide 26, you have filtration, separates insoluble solid that does not sediment, okay, from a liquid. So example is sand from water. Part of the sand will be floating. So you need a filter paper, filter funnel, and a beaker or a conical flask. So the liquid that is separated, is called filtrate, while the solid that remains on the paper is called residue. Then we'll come to decantation. Decantation is just like filtration. The only difference is that we use it to separate solids that can settle down, that can sediment from liquid. Okay, so example is something like stone, separating stone from water, or separating heavy metals from water, heavy metals that don't dissolve. So at the end of the day, the liquid obtained is called decantate. Then the solid remaining is called residue. Then category C, separation of solid from solution. When we say solution, it means that the solid dissolved in the liquid. So we have 6 processes here, or 6 methods. The first one is precipitation. So precipitation involves differential solubility in 2 different liquids. So if a substance is soluble in water but insoluble in ethanol, okay, so the substance is already in the solution of water. If I want it to come out, I will add a little ethanol into that combination. The substance will come out as a precipitate. So it's like a chemical reaction, but it's a separation technique, okay? Precipitation. So the next one is evaporation. Evaporation is used to recover a dissolved solid from a solution. So we normally sacrifice the solvent. The solvent will go. So the key is that if you want to use evaporation, the solid must be resistant to heat. Heat must not destroy it. Okay? Then simple crystallization is used for a solid that heat can destroy. So we just heat it a little and then we stir it. So as it's cooling down and settling down, crystals will start coming out. So that's the way we use crystallization. And it is applied in the industry in extracting drugs, Then fractional crystallization is when you have more than one solid inside a solution and all of them are struggling with temperature. They don't survive extreme heating. So you use fractional crystallization. So the criteria will be the differences in solubility at different temperature. Okay. Then recrystallization is used to purify what has already been crystallized. You want to make it pure. So it's a purification method to make it pure, to improve the purity. So you see this being applied in the pharmaceutical industry where drugs are produced, and also in dye industry where we get dyes. Okay. Now, chromatography. Chromatography is used for organic mixtures, or colored mixtures. So these mixtures move at different rates on the paper, chromatographic paper. So they have different spots that they make, and from there you separate them. Okay. Then we have centrifugation, the centrifuge. Okay. The centrifuge is a machine that spins at different speed. So like the blood, now if you want to separate components of the blood into the cells and the plasma, what do? We spin. So you place the test tube on one side, one corner, then opposite the test tube, you use water of equal volume to balance it. Then you spin. So when you spin, the solid portion will go down and the liquid portion will stay up. So that liquid portion that stays up, we call it the supernatant. Okay. So we can use it to separate milk, can use it to separate blood. Okay. It's used in the medical field mainly. Then column chromatography is just an advanced form of chromatography. So this one is a more advanced technique for separating very complicated mixture. But it's the same thing with chromatography. So chromatography is based on RF value, retention factor. And how do you calculate RF value? The distance moved by the solute or the spot divided by the distance moved by the solvent. So that's how you calculate it in case you see it in an exam. Now, category D is separation of liquid from liquid. So you can have two liquids that don't mix. When you have liquids that don't mix, like water and oil, how do you separate them? You use the separating funnel. So the denser liquid will be at the bottom, the less denser liquid will be at the top. So the tap will create a junction between the two liquids. And once the heavier liquid crosses, the tap closes. So that's how separating funnel is used. Okay. Then another technique is separating a liquid from a solution. Here we have distillation and we also have fractional distillation. So distillation, the simple distillation is just you heat and then the liquid turns to vapor and moves through a condenser and the vapor condenses and forms a pure liquid. But if you now have several liquids, like in crude oil, mixed together, they have different boiling points. So you are going to place a thermometer to monitor their boiling point. So the vapor will start coming out according to their boiling point. So the lowest boiling point will come out first, followed by the next. The highest boiling point will come out last. So as the vapor moves through the condenser, it condenses and you get the pure liquid. So the principle here is that the component with the lower boiling point vaporizes more readily. So these are the separation technique. And this brings us to the end of chemistry. So take a moment to think of what you have learned in chemistry and summarize it in your words. Okay, let's go to physics. So for physics, we are going to be looking at measurement and unit. Measurement and unit. So we need to measure, because if we don't measure, we are not going to be precise. We are going to be making mistakes. We are going to be mixing up ideas. So that's why we need to measure. So for you to measure, there must be an instrument you are using to measure. Then there must be a unit in which you are measuring. So if I take water now into a container, that container becomes my instrument of measuring the water. Then the unit may be milliliter, or it may be liter, or it may be centiliter, or it may be centimeter cube, or whatever. That's the unit. So as we all know, physics is already defined as the study of physical quantities. Okay? So a physical quantity is a measurable property that can be expressed using a numerical value and a unit. This is why it's not proper to just come and say you are trying to describe something you are measuring, then you just say the length is 20. the length is 20 doesn't really make sense. The length is 20 what? Is it 20 kilometer? Is it 20 meters? Is it 20 millimeter? And all that. So that's the reason for this topic. Okay. So we are going to look at the types of physical quantities. We have the fundamental quantities and the derived quantities. So the fundamental quantities are independent and cannot be derived from other physical quantities. So they are directly measured. That's why they are called fundamental. They are the foundation of other measurements in physics. So we have 7 fundamental quantities with their SI unit. When we say SI unit, that's the standard unit recognized globally. So let's look at them. The first one is the length. The SI unit of length is meter. The symbol of the unit is small letter m, and the instrument is meter rule. The next is mass. The SI unit is kilogram. The symbol of the unit is kg, and the instrument is beam or electronic balance. The next is time. The SI unit is second, and the symbol of the second is small letter s, and then the instrument is stopwatch or stop clock. The next is temperature. Temperature SI unit is Kelvin, and the symbol is K, capital letter K, and the instrument is thermometer. The next is electric current. The SI unit is ampere. The symbol of ampere is A, capital letter A, and the instrument is ammeter. The next is amount of substance. The SI unit is mole. The symbol is MOL, and the instrument is spectrometer. Okay, we use the spectrometer to measure mole, even though the main use of it is for mass of isotope. It can also be used to measure mole. Then luminous intensity. The SI unit is candela, and the symbol of candela is CD. Then the instrument is photometer. Okay. So note that derived quantities are those that can be expressed in terms of other fundamental quantities. So derived quantities are obtained from the combination of fundamental quantities. So example is area. Area is combination of length. That's why it's meter squared. Volume is also combination of length into 3. That's why it's meter cube. Density is combination of mass and length into 3. That's why it's kilogram per meter cube. Speed is combination of length and time. That's why it's meters per second. So those are derived quantities. So let's look at more examples of derived quantities. We have force. Force is mass times acceleration. So the unit becomes kilogram meter per second squared, or Newton, named after Isaac Newton. Okay. Then frame of reference. Frame of reference just refers to a coordinate system or point relative to which the position or motion of an object is described. So if you are describing movement, what is the reference? Where are you looking at as your standard or starting point? That's what we mean. So at rest, relative to another passenger, or in motion relative to a person standing beside the road. These are the ways we can describe the moving bus. Okay. Therefore, motion is relative to a chosen frame of reference. So if you are traveling, for example, in a bus, you notice that it looks as if you are not moving, but the forest is moving around you. If you travel by flight, it looks as if the cloud is not moving. No, it looks as if the cloud is moving while you and the plane is in a position. So that's why we say motion is relative when you look at it from that angle. Then the degree of accuracy refers to how close a measured value is to the true or accepted value. So we express it in percentage. The instrument used affects the accuracy of measurement. So if you don't set it well, it can lead to error. So you always do what we call, you eliminate zero error before you use an instrument by setting it to start from 0. But assuming it doesn't start from 0, what do? If it starts from 2 and you get a measurement of 10, what do? You subtract 2 from 10. The actual measurement becomes 8. That's how to eliminate zero error. So common examples. A meter rule, smaller precision smaller precision than vernier caliper. So vernier caliper is more precise than meter rule. The vernier caliper more precise than an ordinary meter rule. The micrometer screw gauge generally more precise than a vernier caliper for very small dimensions. Then there's what we call Cartesian coordinate. A Cartesian coordinate system uses axes to locate the position of an object. So the common two-dimensional system is x in the horizontal dimension and y in the vertical dimension. So we put it in brackets and x value comes before y value. So bracket x comma y close bracket. So like the origin where the coordinate begins is 0, 0. At that point, x is equal to 0, y equals 0. But if I give you 2, 5, it means that x is 2, y is 5. So you should be able to interpret that. Now, a point may be what I just explained, p, x, y. For example, p, 3, 4 means 3 units along the x-axis and 4 units along the y-axis. Okay? So vernier caliper. A vernier caliper is used for accurate measurement of external diameter, internal diameter, depth, thickness. These are the things we use vernier caliper to measure. Okay? We'll go to the next slide, 36. Micrometer screw gauge is used to measure very small dimensions such as diameter of a thin wire, thickness of a sheet, diameter of a small object. Now let's give an example. If you want to interpret the reading of a micrometer screw gauge, the total reading is the sleeve or main scale reading plus the thimble reading. So the main scale, for example, maybe you got 5.50 millimeter, then the thimble reading is 0.28. Normally you see it as 28, but it is 0.28 when you are writing it. Then you add up the two, you get 5.78 millimeter. Okay? Always check for zero error when the instrument is not properly calibrated. I've explained this earlier. So we move on. For vernier reading, if you want to read vernier, is the main scale reading plus the vernier scale reading. Example, suppose the main scale reading is 2.3 cm. Vernier coincidence, that's coincidence where the lines, the two lines, the one in the vernier and the minor scale, where they are on the same line is 6. Then least count is 0.01. So you multiply 0.01 by 6, you get 0.06. Therefore, total reading will be 2.30 plus 0.06, which gives 2.36 centimeter. I hope that is clear. So we move to the next slide, dimensional analysis. So dimensional analysis is just like a mathematical way to describe the fundamental and derived quantities based on their units. So common symbols, mass is represented by capital letter M, length, capital letter L, time, capital letter T. So examples, velocity is displacement divided by time, okay, which gives L over T. That is L T raised to power minus 1. So we simply say L per T. Acceleration, velocity divided by time. That is L per T squared. Force, mass times acceleration, which is L ml per T squared. Okay? So you should be able to write all that. Then we can use dimensional analysis to check for the correctness of equation. In the next slide now, slide 39, let's see that. Both sides of a physically correct equation must have the same dimension. So, for example, V is equal to U plus AT. Let's check it. Dimension of V is what? L per T. U is also L per T. Then let's check AT. AT is L per T squared times T. So T will cancel one of the T. You now have L per T. Therefore, the equation is dimensionally correct. Dimensional analysis can test whether an equation is dimensionally possible, but it cannot prove that the numerical constants or mathematical form are correct. For example, if I have T is equal to 2 pi root L over G, you cannot prove the 2 pi because of that one is a constant. So when you are proving your equation, any constant, don't bother about it. Just face the quantities, the physical quantities, okay? So that's what we have. Then We can also classify these quantities into scalars and vectors. So scalar is a physical quantity that has magnitude but no direction, while a vector is a physical quantity that has both magnitude and direction. So I'm just going to give you 3 illustrations. Distance is a scalar quantity because it has magnitude. Displacement is a vector quantity. It has both magnitude and direction. But you know, these two terms are used as if they are the same. They are not the same. If you are describing displacement, you will mention the bearing, like north or east or west or south. But if you are describing distance, you only mention the distance without the bearing. Okay? Then speed and velocity. Speed is a scalar quantity. Velocity is a vector quantity. Then mass and weight. Mass is a scalar quantity. Weight is a vector quantity. Impulse and momentum. Impulse is a scalar quantity. Momentum is a vector quantity. Work and energy. Energy is a scalar quantity. Work has direction and magnitude. So work is a vector quantity. So we are good at this point. We are going straight to mathematics, which is our last subject for today. Mathematics, very important subject for those of us going for engineering and management courses. So mathematics, the topic we are treating today is the very first in the syllabus, number basis. So for you to start this topic, you have to first of all know the order of operation. Order of operation. You remember BODMAS, okay? BODMAS, B for bracket, O for off, okay? Off or indices. D for division, M for multiplication, A for addition, S for subtraction. So if you are given a group of operations to perform, it means that you will follow this order. Example, 8 plus 3 times 4. You will do multiplication first according to BODMAS. So 3 times 4 is 12. Then you now add. So the answer will be what? 20. If you don't do it like that, you will fail it. Like if you do 8 plus 3, 11. 11 times 4, 44. And JAMB will give you the option for that wrong answer. They will give you. So follow BODMAS in any arithmetic operation you are doing. Example 2, 10 minus 4 in bracket, then times 3. So you settle the bracket first. You get 6. Then multiply by 3, you get 18. Okay? Now look at this exercise. Evaluate 18 minus 6 over 3 plus 2. This is from JAMB. So you divide first. Okay? Division will happen first. 6 over 3 is 2. You place it there. 18 minus 2 plus 2. Then when you have done that, what do you do next? You add. So minus 2 plus 2 is 0. Then the last operation, the answer is 18. We'll go to another example. Evaluate 4 plus 3 bracket 8 minus 5. So let's deal with the bracket first. 8 minus 5 is 3. So this is 4 plus, okay, you multiply next. 3 times 3, 9. So it simply means 4 plus 9, 13. 13 is the answer. If you don't follow that, you get a wrong answer. Then the next one is 20 divided by bracket 2 plus 3, then times 4. So what do we do first? Bracket 2 plus 3, 5. Then the next is division. Division before multiplication. So 20 divided by 5, 4. Okay, then 4 times 4, 16. The answer is 16. More examples. The next one, 23 plus 12 divided by 4 times 2. So, what do we do first? We are going to divide. Okay? So, 12 divided by 4 is 3. Okay? Then the next one is you multiply. 3 times 2 is 6. Then what do you do next? You add up. So when you add up, I think there is a mistake there. That thing shouldn't be 23. That thing is 2. There is an error there. Okay? That's 2 raised to power 3. Yes, not 23. 2 raised to power 3. That's 8. You do it first. So at the end of the day, you add up 8 plus 6, you get 14. Please, that thing is not 23. That order first is 2 raised to power 3, 8. Then, number 5, evaluate 30 minus big bracket 4 plus 2 small bracket 5 minus 3. So you deal with the small bracket first. You get 2. Then you move to the next level, 2 times 2, 4. Then you add inside the bracket, 4 plus 4, 8. Then you now bring it out and do subtraction last. 30 minus 8, 22. So the answer is 22. So we are good with board mass. Please, everybody should practice board mass. Set question for yourself and deal with it. Number basis now. A number base determines how many digits are used in a number system. So base 2 is binary, 0 and 1. So binary is what they use for all this your electronics. That's why your switch, you have on and off. Off is 0, on is 1. Okay? All these things we learn, they apply it in real life. Then base 5 is 0, 1, 2, 3, 4. Those are the digits you have. Base 8, you have 0 to 7. Base 10, you have 0 to 9. There is no 10 inside base 10. Then base 16, you have 0 to 9, then A to F. Though in JAMB, we don't do base 16. So the general rule is that in base n, the largest single digit is n minus 1. So if base 10 now, it will be 10 minus 1, which is base 9, which is 9. So converting from any base to base 10, what do? You multiply each digit by the appropriate power of the base. But if you are doing the opposite, you divide. So let's see. Convert 1011 base 2 to base 10. What do? You write them, multiples of the base. Then you start from the last one and you start raising the power 0, 1, 2, 3. So you solve them individually, you get 8 plus 0 plus 2 plus 1, which is 11 base 10. Okay? We'll go to the next. Example 2. Convert 132 base 4 to base 10. You do the same thing. 1 times 4 to power 2 plus 3 times 4 to power 1 plus 2 times 4 to power 0. So this gives you 16 plus 12 plus 2. Remember that anything raised to power 0 is 1. So when you do this, you get 30 to base 10. Okay? Now, converting from base 10 to another base. That's the next one. So use repeated division by the required base and read the remainders from bottom to top. Then combine them. So convert base 25 to base in base 10 to base 2. So you see it, use that base 2 to be divided. 25 divided by 2 is 12, remainder 1. 12 divided by 2 is 6, remainder 0, no remainder. 6 divided by 2 is 3, remainder 0. 3 divided by 2 is 1, remainder 1. 1 divided by 2 is 0, remainder 1. At this point, once you get an answer 0, you stop the division, remainder 1. Then you take your arrow, point it from the bottom answer to the top answer. So you now write 11001. 11001 to base 2. You are reading upward. So that's the answer. Let's look at another one. Converting from one base to another. Now they didn't tell you whether it's 10 to that or that to 10. What do? This is where JAMB, this is the kind of question JAMB like setting. So what do? My advice is that convert to base 10 first, because base 10 is always easy. Then from that base 10, go to the base you are looking for. So for example, convert 132 base 4 to base 2. What do? Let's convert it to base 10 first. So when you convert to base 10, you get 30 in base 10. Now convert 30 in base 10 to base 2. You divide 2 by 2. So when you divide 15 remainder 0, 15 divided by 2, 7 remainder 1, 7 divided by 2, 3 remainder 1, 3 divided by 2, 1 remainder 1, 1 divided by 2, 0 remainder 1. Then you add them up. You get 11110 base 2. So please follow this method. Don't complicate. Don't go and learn one kind of shortcut that will confuse you. Follow this method. It will help you. Okay? Now let's look at exercises. These exercises, I want everybody that is part of this program to solve them, because we don't joke here. So solve this question, and when you finish solving, take a picture of it with your phone and submit it to our WhatsApp number with your name on it. write your name, take a picture of it with your phone, and submit it to our WhatsApp number. That will show us that you are following what we are doing. Okay? So please, our next class is on Saturday, the 29th of August by 8:30 a.m. to 10:30 a.m. Okay? That's the live class. Please always be in the live class so that you can ask your question, you can interact. If you miss the live class, you don't need to worry. We'll keep the recording in our YouTube channel. You go there and watch it. Even if you have attended the live class, go back again and watch the recorded class so that some things you've forgotten, you write them down, So don't forget that our free classes end in this August. From September, we make payments 10,000 naira per month for the lesson. So for the 8 months that are ahead, it's supposed to be 80,000. But for those who will pay at once, they can pay 50,000 and know they've paid for the whole year. So this lesson is basically for the sciences, because you can see we are covering the science classes. But if you're an art student, you can join us doing English. After English, you can leave, no problem. Then we have our CBT practice package. So that's the one that is for everybody. Our CBT is like no other. So each question, you choose the answer, then you choose the reason for the answer. You don't cram and come and write our CBT. Then after you've written, you see your result, an analysis of how you did well, the areas of challenge, how you should do your next one to improve. We'll give you that, and then we'll give you correction. So with that, we have come to the end of this class. Hope to see you in our next class, 8:30 a.m. to 10:30 a.m. Please remember to subscribe to our channel, to comment, to like, and then share with your friends that are writing JAMB. Let them also come to our channel to watch. If they want to join the live classes, tell them to send a message through WhatsApp to us, and then we'll add the person. Thank you for your attention. God bless you. I remain teacher biochemist Emmanuel Ndubisi. See you next class.